All right, so here's number 14. We've already started, so I'll just catch up real quick here. So number 14, we have rockets being launched at a festival, whether they're fireworks or whatever. We're proposing that this is a projectile that goes up and then comes back down. It's modeled by this function right here. H of t is negative 4.9 t squared plus 80 times t. So the h stands for height. Okay, h is height. The units are meters, okay? So the quantity is height, the units are meters. For t, the t is time, and the unit is seconds, okay? Now, the question I first asked was, where is the rocket at time 0 when this whole situation begins to unfold? And the answer is at h equals 0, because when you put t equals 0 into the equation, you have h, where t is 0, is negative 4.9 times 0 squared plus 80 times 0, which h evaluated at time of 0, that's what that means, h of 0 is 0 plus 0. So h of 0 is 0. Now this is called function notation, and we're going to get into more of that as we move through math, but really h of 0, that just means h at time 0 is 0. So at the beginning, the rocket launches from the ground. It doesn't launch from the side of a hill. Okay, not up here. It doesn't launch from a tall building up on top. Doesn't launch from there. It launches from the ground. And we know that because at t equals 0, we have height 0, okay? Now, this is a quadratic, so we said the shape is a parabola. And parabolas are symmetrical, so they go up and then they come down at the same rate. I'm going to try and draw that as symmetrical as possible. Now, the question asks about domain and range. So what is the domain? Just explain it to me in words. What is the domain here in this question? All real numbers. Interesting. Okay. For what quantity? What are we measuring the domain for? What's the quantity? Time, right? Because domain is the x value, which in this case is time. Okay. Now, you said the domain is all real numbers. Let's think about that for a second. Okay. It is true that decimals to the billionth of a second is possible. So there we can have decimals and radicals and irrational numbers and all fractions, everything. But does the time in this question extend forever to negative infinity and forever to positive infinity? Does that make sense? Okay, so let's think about this exact thing. It makes sense that we're going to start at time 0. So part of the domain is it's the time for the question, okay, for the question, okay? And so that's going to start at 0. So time 1 is 0, and it's going to go all the way till, what does this point represent?
When the rocket lands.
Okay, when the rocket lands back on the ground, okay? Now, they have a picture of fireworks. I don't like thinking of fireworks because fireworks like go up and then explode and don't really come down, right? So let's think about it's like a rocket. It's a projectile that goes up and down because this is a parabola, clearly. So yeah, so this is where the rocket hits the ground. Now, after that, this parabola doesn't make any sense anymore because it's not going to continue down under the earth as time goes on, right? It's not going to do that. So then the end of the domain is going to be the time when the rocket hits the ground. Now, how do we find out what this time 2 is? It's when it hits the ground. What does it mean when it hits the ground? When it's on the ground, what else in this question? What does that mean? Thank you. The height is back at 0 right here. Okay? So there's going to be 2 times where the height is 0. One, time 0 when height is 0, and then time 2 when height is 0. So now we have to figure out what that is, and that's right now the tricky part. So there's only so much math you guys are familiar with, but you should be familiar with factoring, and we have to work on factoring this chapter, I believe. I'm going to have a little extra work, some factoring practice for you, because factoring is huge. Quadratics, one of the main things in high school and university math, okay? Parabolas and how they work and what they represent, that's huge. Also factoring. If you cannot factor, you're going to struggle. So we're going to work on factoring too. Now, let's go back here. So I'm going to erase some of this stuff. H is 0. Yes, that's true. But I need to find the other t that makes h 0. Okay, so watch what I'm doing here. I'll rewrite this. Okay, so I need to find out when height is 0, what is the time? That is negative 4.9 times t squared plus 80t. I need to solve for t. Now, if t was just in one spot with one term, I could easily shuffle everything around, get everything over to the right side or left side or whatever, and then isolate for t. But that's not the case here because I have two unlike terms. I have a t squared and a t. So you can't just get t all by itself here. That doesn't work that way. But we are going to factor, okay? Now, this looks complicated. It's not really. Look at these two terms. I have a negative 4.9 t squared and I have a positive 80t. What is the common factor?
T.
The common factor is t, because this is negative 4.9 times t times t. This one is 80 times t, so t is a common factor. So this equation becomes, I pull a t out, and again, you're just separating it. Factoring is separate. You're not getting rid of it. You're just separating it. And so I have t times, what do I multiply to get this? So basically, this divided by t is negative 4.9t. You do have to have the t in there. And then when I divide a t out of this one, it becomes just 80. Okay, awesome. Okay, that's good. A lot of you just said that all at the same time, so I'm happy about that. So from here, I want you to see that there's a special situation here. I have this term times this collection of terms. So this thing 1, times this, thing 2. Okay? And so if the product is to be 0, that means that either this or this has to be equal to 0. And so to find the times where this function is 0, I am going to let t equal 0, and then I'm going to let this equal 0, and I'm going to find that time. Okay? So you can see that if t equals 0, that satisfies this factor being 0, right? And that's this one. So this one, what I have to do, and I'm going to show you today in 7.3 how to do this graphically with a graphing calculator. It's going to be awesome. But right now, algebraically, you can factor and find out what this is. So negative 4.9t plus 80, that has to equal 0 as well as the second factor that can equal 0. And so now I have t in one spot. I just solve for t. I divide. And then I get t equals, somebody do that on their calculator. It should be about 16.3 something.
16.32.
So 3.2. What's the third decimal?
6.
Okay, 326. Just a hint, in AP, in the advanced placement exam in calculus, if you do that in 2 years from now, then the criteria for rounding decimals is 3 decimal places. And you don't even have to round it. You can round the third decimal place, you don't have to. So I'm going to try and do 3 decimal places a lot of times with you guys, just to kind of get you prepared for that. So this is seconds, right? Okay, so that means here, 16.326 seconds is when it lands. So it's in the air for a total of 16 seconds, or thereabouts. All right, so that means, now this is, I'm taking a long time, but I'm trying to explain this as well. So that means that the domain goes from 0 all the way, including 0, all the way, now this t is the variable, all the way to 16.326. And that's how you would write that. The t values are between 0, that's greater than or equal to 0, and also at the same time being less than or equal to 16.326. So that's the domain there. Anybody get that? On your own? Yes, independently, before we did it? 1? Okay. All right, now the range, let's talk about the range. Remember, the range is all possible what values? Y values is the range. The y values here are the heights. So we know that the minimum height, because the rocket cannot go underground, can't travel underground, so we're going to say that height 0 is the minimum point. Everybody understand that? And we're going to try and find out what this maximum value is here at the apex, at the top of the path. It's also called the vertex. Remember that from the other day? It's the vertex. So I need to find the vertex. right now, there's lots of different mathematical ways we could do this, but right now, what you guys know is that parabolas are symmetrical, and this parabola that I drew does not look totally symmetrical, I apologize. But parabolas are symmetrical. That means that if you have any 2 points,
Good morning, high school.
when you have a horizontal line, these intersection points right here, in between those, exactly in between those, will be the vertex. Always. It doesn't matter which horizontal line you draw, the value that's right in between them will be the vertex, and that includes your x-intercepts. So the vertex is exactly in between 0 and 16.326. That's where the time is. This is the vertex. Time of vertex is exactly halfway. So vertex x value is 16.326 minus 0 divided by 2. That's going to be what? 18.163? Sorry, 8.163? Does that look about right? Did I do that on the calculator? No. Okay, so that's the x value of the vertex. Now, in order to get the height, what I need to do is I need to find out what h is when t is 8.163. And that shouldn't be a big problem. We go h of 8.163. So that's the height taken at time 8.163. That's going to be negative 4.9 times 8.163 squared plus 80 times 8.163. Okay, so you plug in this value if you want the corresponding height. And that h is going to be... All right, so I'm going to put this in the graphing calculator. All right, I don't want alpha now. And I'm going to graph this function, okay? So it's going to be, okay, well, I'll just go zoom 6. You're going to find that this looks really bad. Look, you can hardly tell, but it goes through 0, but it goes super high, and then comes back down. So I'm going to have to change the window here, which I will go through this in the next lesson. But x min, I'm going to go just before 0. X max, we saw in our diagram that the rocket's in the air for at least 16 seconds, right? So let's go to like 20 or something. And then the height might be really, really high. So I don't have to go much below 0. I'll go minus 5. And then the max, let's do like 500 or something. I don't know how high it's going to go. So let's graph it. Look at that. There's the parabola that I'm looking for. Okay? And if I say I want to know what the height is for that 8.1 value, 8.163, okay? Hello. Okay, so I'm just going to go into my calculate menu. I'm going to hit value. We'll go over this in more detail later. I'm going to put 8.163, 326.530 or 1. So 326.531. Put the 1 there. Okay. So 326.531. And so that's going to be in meters. So my range is going to be 0. It's h, and it goes all the way up to and including 326.531. And that would be fine. Even if you round up on that decimal, I'm okay to put the equal sign there. All right, so that's a big question there. And if you didn't attempt that in your homework, small shame on you. But this is kind of stuff that this is why you need to work through your homework, guys, okay? If you focus on this right here, and that's all you get done, because this is what you can do in class the time I give you, and you don't ever push through, then you're not ever going to push through into any kind of deeper understanding, okay? So I challenge you, please make sure you at least attempt your questions that I assign you. All right. So we are going to move on to 7.3 here now, but that is number 14. Any final questions there about that one? Yeah, good? All right.
That was easy.
Wasn't that easy?